something? Let's find out about codes and deciphering. What you doing here? Codes and deciphering, of course. Let me ask you, do you know about codes and deciphering? You know? No? Did you know that math involves in codes and deciphering? You know? You came to the right place. Hey, you seem bored. Let's pop some volume here. Thank you, my man. Okay, basically, codes and deciphering, they have involved math in it. What? What? How? So, I'm gonna tell you, Fibonacci sequence have math in it. Let's find out. First of all, we have to know who is Fibonacci. Well, he is one of the famous mathematicians in the Middle Ages. Well, his real name is Leonardo Pisa. Why Pisa? He's born there. So he's Italian. People call him Leonardo Pisano. Okay, why Fibonacci? Actually, Fibonacci is the short form of Filius Bonacci, which is the son of Bonacci. Well, to know more, let's find out more. One of the famous Fibonacci thing is the Fibonacci sequence. Well, it involves a lot of math in it, so I would like Faiz to explain to you about what Fibonacci sequence is. Let's find out.
Well, hello there. So now I'm gonna continue what I was told you before. As you can see, this is the formula to find the Fibonacci sequence here. This is the original sequence, and I've made a bit of change here. As you can see, this Fn is the original formula to get this one, but we change it to Fn minus 1. So I'm going to show you why we change it, because you can see there's a 1 here and 1, 1. So it's not going to represent the same numbers in the different letters. So we made a bit of change. Going to make it 1, 2, 3, 5, 8. So how do we get this one? By this formula. As you can see, if I want to find the fourth term, I need to put a number of 5, which is 5 and not going to be 4. So 5 is going to be the end. So 5 is here and 5 is here. So when we calculate, we're going to get 5, which is this number. So this is how we came up with this one. So let's get to the code now. Okay, hello again. So this is the sequence, Fibonacci sequence, and the letter represents each sequence. As you can see, 1 is a A, 2 is a B, 3 is a C, D is a 5, and so on. It should go on until Z, but we didn't put it because it's going to be long and the complexity is going to increase. So we let it until O here. So I'm gonna show you on how to make the code. For example, if you want to code the word bank, B-A-N-K, the code should be the sum of the total number that represents each of the letters. As you can see here, if you do word bank, it's going to plus 1, plus the 2, plus 144, plus 610. The total of that number is going to be the code of the word bank. Okay, so now we're here. So I have this number besides me and this number besides me. So based on this number is the code that I need you to decipher. Or if you can't, I'm gonna ask my friend Fiddles to do it.
Hi, let's continue what Faiz has said. So now I'm going to guide you guys to inscribe the code, the Fibonacci code. First, the first step will be eliminate the alphabet which is not possible. Then we have to eliminate the combination of alphabet which is not possible in the word. And then the third one, we have to analyze the most used alphabet in any language. For this example, the particular will be in English. Okay, the English and the most alphabet used is the vocals A, E, I, O, U. Okay, for number 4, we have tried all the possibilities and try to formulate a word. Okay, let's try the example. Okay, now we try to describe this code 24. Okay, the code 24 refers to the total number in a word. Okay, in this case, we have 3 letters. Okay, now we have to eliminate all the possibilities which cannot exist in the code. First, eliminate the greater number of code 24H, and then eliminate the pairs that cannot be together in code. So we have to eliminate F and G. Okay, now we know that it's 24. So from this code, we have to find the possibilities of getting 24. In this case, we have E, which is 8, F, which is 13, E, which is C, add up together, you get 24. And then for the second possibility, you get G, A, and B, you got 24 also. And try to generate a word from these possibilities to form a word. And you can try all you can, but you are going nowhere. For this one, you're going to get bag. So, in your reality, imagine that you have no hint and you just get any number, particular number, 1500. So, how are you going to encode this one? Alright, it is going to be hard, so then I just give you an exercise to make sure you understand. Try to encode the code 11. So that's all for me.
I will start with the Caesar cipher. In the Roman era, a person called Julius Caesar, he introduced the Caesar cipher because he wanted to conceal his military message. Each letter in the message will replace with a different letter to form a code.
Now that we know what Caesar cipher is, we can begin to decipher the code. Before we decipher, we should know that Caesar cipher is all about shifting down alphabets. So because of that, we must first assign numbers to the English alphabet according to the order in which they come out. So for example, A is equals to 0, and then it's followed by B, which is equals to 1, C, which is equals to 2, D, which is equals to 3, and so on and so forth until we arrive at the last alphabet, Z, which is equals to 25. And after that, the term that we need to know in deciphering Caesar cipher is shift key. Shift key is the number of times that we're going to shift a certain alphabet. For example, if the shift key is equals to 3, the letter A, we're going to shift it down by 3. So it's going to move down by 1, 2, 3. So the code will become D. Okay. Now we can begin deciphering the Caesar cipher. To decipher it, we focus on one simple formula, which is X is equals to Y minus N mod 26, where Y is the code, X is the plain text, and N is the shift key. Mod 26 comes in when the number that you get is less than 0, so we have to plus it by 26. For example, I have a code here which is WNHJ, and the shift key is 5. So to decipher this code, we have to decipher it letter by letter. First, we begin with W. W corresponds with the number 22 in the alphabetical order. So we substitute Y with 22, we substitute N with the shift key, which is 5. So 22 minus 5 is equals to 17. So 17 corresponds with the letter R. And so we have our first letter of the actual message that they're trying to give us. And so we move on into the next letter, which is N. N corresponds with number 13. 13 minus 5 is equals to 8, which corresponds to the letter I. And then we begin to the third letter, H. H corresponds with the number 7. And we minus it by the shift key 5, we get 2, which corresponds to the letter C. And the last letter, J, which is number 9 in the alphabetical order, we're going to minus it by 5, and we get 4. 4 corresponds to the letter E. So the plain text that we get is R-I-C-E, rice. Okay, so this is a simpler code. Now we move on into a more complicated one. So I have TRCTLCLG, and the shift key I received is 17. So using the formula, T, which corresponds to the number 19, we minus it by the shift key 17, we get 2, which corresponds to the letter C. And then R, which corresponds to the number 17. We minus it by 17, we get 0, which is A. Now C, I'm so sorry, C, which is in the alphabet, it's number 2. And now when we minus it by 17, we get negative 15. Now this is less than 0, and this is where mod 26 comes in. When the number is less than 0, we have to plus it by 26, and so it becomes 9, which corresponds to the letter L. And so we have P again, and now we have L, which corresponds to the number 11. We minus it by 17, we get negative 6, and then we plus it by 26, and we get 20, which corresponds to the letter U. Now we have C again, which corresponds to the letter L, and L, which corresponds to the letter U, and J, which becomes the letter S. And so the plain text that we get is CAL, CU, and US, calculus. And so now we know how to decipher the Caesar cipher.
For people like us who are deciphering the code centuries later and without knowing the shift key, deciphering Caesar cipher is hard, but it is not impossible. Caesar specialists have used the method called frequency analysis. Based on a statistic, the letter E is the most frequently used in the English alphabet, and the letter Z is the least used in the English alphabet. This analysis is used to determine the letter which appear the most number of times in the code. Using this fact, it is assumed that the most used letter in the code corresponds to the letter E, and basing our shift key from there. Of course, this is based on trial and error. And if the first shift key does not produce message, the second shift key will be tried using the second most used letter, and so on.
Okay. In conclusion, our group have chosen ciphers and codes for our project. As for example, we have taken Fibonacci and Caesars to be our example. Fibonacci code is a summation of Fibonacci numbers known as 1, 1, 2, 3, 5, and so on. The next number is a summation of two previous terms. The Fibonacci numbers represents each letter. In order to decode it, we have to find the possibilities of a summation of the number. No definite ways have been given to decode this. We came up with our own guidelines as to solve the problem. The letters are then arranged to form words. As for Caesars, each letter in the alphabet represents the number between 0 to 25, with A equals to 0 and Z equals to 25. The shift key is the most vital part in this process, as without it there's no point in breaking the code. The decoder has to shift the letters according to the shift key in order to get to the actual letter. These two methods have one thing in common. Both uses the frequency analysis. It shows the most frequently used letter in the particular language. The most frequent letter have the highest possibility to come up in a word. Thank you very much. I hope you enjoyed the video.